Thank you very much, Theodoros. So I think we already have one question for you. And let me share my screen. This is something you discussed a bit on during your presentation, but maybe you can say a bit more on this. Someone is asking, as far as the Mediterranean climate and the very mild, unpredictable and variant weather in Greece, do you think that airtightness is really important in residential applications? It seems that users are okay with just opening windows, as heating and cooling requirements seems to be very low. What can you say on this?
Yeah, of course. As we saw, we know that we can build houses and buildings with 15 kilowatt hours per square meter, and we consume 300. So the numbers and the cost of energy is the answer, that we spend much more energy for heating in Greece with 2-3 months. Other point is important for cooling and heating, not only in Greece, but in Spain, in California, and everywhere. So we invite people to read and the AIVC, all the papers, that there is a misconception that if it's a warm climate, we don't need energy. We do need energy, and we do need to have an envelope. So we are open to speak more about this. We have more, that's what we do in our association. We share also studies from other countries that have a lot to share, and we invite in larger discussions about this. So yes, independently of the Mediterranean climate, where France also in the Mediterranean, Spain, they do have, we saw France is leading as a Mediterranean country. So we have a lot to share and see information about this.
Yeah, thank you. If I remember well, in your presentation during the AIVC conference, you mentioned that Greece was consuming maybe about as much energy as Norway. Do I remember well? Because Norway is very good at airtightness.
Yeah, well, in Finland, there was a study by Greenpeace. Greenpeace has proved that in Greece we spend more for heating energy comparing to Finland. So numbers are talking by themselves.
I think it's a very good answer to that question, because if you had very airtight buildings, then you should consume much less than a country as Norway. Finland,
well, obviously, well, the misconception is that we believe that houses have to be airtight, which means we do not open our windows. It's wrong. We can live with the windows open. We do not have to change our way of living. Obviously, we're not talking, I mean, if I have a good weather, I open my window, I have inside out area the same. It's obviously, nobody says you have to stay close in your house. But when you have the same temperature, if you have a different temperature, if you have 40 degrees outside or you have 10 degrees outside, you close your windows, and then you need airtightness. So it's clear, I believe.
Yes, thank you. We had another question. I suppose it was for you. Is there a typical cost per square meter for airtightness testing?
There are typical costs per cubic meter, actually. And it depends on the market. The freelancers, each freelancer can do his offer. So more or less are the same costs are around Europe, and depends on what kind of test do you need. Do you need a test just to have a measurement, or do you need a test to control the envelope during the construction, which is much more important. So it's important to use the blower door test not as a result, but as an instrument to make a better construction. So costs can start in Greece from 300, 400 up to 1,000, depends on the cubic meters and how many hours and how many people have to work around the envelope. So more or less is the same, I believe, in Europe. It depends on what you want to do. There is not one point. You just ask for a test. It's better to use it as an instrument, not as a controller.
Okay, thank you. One more question. Is there a factor that measures stuffiness? I'm not sure to understand what is meant, but maybe you do, because I think that it is the main reason why people are not fans of airtightness.
Well, I have a whole presentation regarding the habits. The habits, I believe, stuffiness. Maybe we want to say that we suffocate. We don't feel good in our in a very closed envelope. I feel the same. I need fresh air, but fresh air should be controlled. So I believe, if I'm correct, to measure the stuffiness means to measure the quality, the indoor air quality. If we have good air tightness, we can control the indoor air quality much better than if we have a destroyed envelope. So I believe that the answer to this question is people feel better if we have good fresh air, good temperature, and good and levels of humidity and correct CO2 in the correct levels. So this is the main people are not fans of air tightness because they believe that they need fresh air, but there is a lot of work behind this controlling ventilation.
And a related question, what is the flow rate in cubic meters per hour that is required in nearly zero energy buildings?
Well, this fashion of NZ buildings is a big name. Depends on what you consider NZ building. I believe that NZ building has to consume less than 15 kilowatt hours per square meter. So it depends on the protocol, it depends on the climate, and depends on where you build this building. And the cubic meters per hour in NZ building, do you mean N50 or QE50? Where there are labels and there are there are some tables. N50, okay. If you're talking about N50, we can say that would be better less than 0.75. Minus 0.75 would be a good number, I believe, but there are a lot of researchers that can give answers, and there are a lot of papers published on this opinion. This is my opinion. Less than 0.75, it's okay for me. But there is no a law or something, a specific legislation.
If other speakers want to answer, feel free also. I'm not sure if you have other information to give, but oh, okay, we have more questions. Someone is saying, I have visited passive houses that are airtight, and it gave me a feeling of stale air, not freshness. Okay, so it's related to the previous question. Can this be improved? Maybe more fresh air input per hour?
Well, that's the point. I repeat and I keep saying that a building is an alive organization. Is like a human being. Okay, depends on the people who live in the building, depends on the way they live in the building, depends on their habits. So it could depend of many things. It's not something automatic. You can have two same buildings and you can have different perception of indoor air quality, and that depends on the owner. It's not on the building. So it's a very generic question, I believe. So it's not a passive house. It depends on also who uses the passive house. I mean, we have built passive houses and people were using it in the wrong way, and they consumed more. There are a lot of things, I believe, regarding the freshness that you can feel. Of course, you can improve by the machines that you use, by the habits you have. Of course, can be used. A passive house is a very good instrument, a very good machine to use for better indoor air quality.
Okay, thank you. And one more question. How do you think we can make people be interested in improving their airtightness?
First, they have to understand that can save them money. If you build a house, if you buy a house and you make an investment and you want this investment to return to you, you have to have good airtightness. And second of all, you live better. You have better health. You live better. So people have to connect airtightness with their investment, with their money. It's a very small, because airtightness is not only the test, is how to design airtightness. There are materials for airtightness. There are companies that produce materials for airtightness, and there are different ways of building. So people should understand that airtightness is the key factor for saving money, for receiving their investment, and for living better.
Okay, thank you. And we also have one question that is for, I think, all speakers. So duct airtightness alone is insufficient to determine air handling system leakage airflows, which depend on the leak pressure differences and can significantly affect fan energy use in large commercial buildings. ASHRAE standard 215 provides a method of test for determining leakage airflows during system operation at a repeatable reference operation condition. Is there a reason that this standard is not used in Europe? Does anyone has an answer to that question? No?
Sorry, I don't know this standard, so I'm not able to give an answer.
I just can say that in the energy calculation method in the French regulation, we take into account also the operating pressure difference. Of course, we use the measured class of air permeability, and then in the calculation method, you have to give the pressure difference of operation of the system to calculate the heat loss.
Yes, I think it's the case in several countries. I don't have really the details in mind, but I think several countries do the test at the operating pressure. So I think the results is okay.
In France, we have the rule is we have a reference pressure difference to perform the test, but if this reference is very different from the operational pressure difference, we have to perform two tests, one at the reference value and another one at the operational value. So we do both if there is a difference between these two values.
Okay, I hope that answered the question. I think we have addressed all questions. So if there is not any more, we can close this webinar. So I would like to thank all speakers, but also all of you for attending this webinar. I think we were over 130 today, so thank you. And don't forget to register maybe for next week webinar if you want to know more in 3 other countries, Latvia, Czech Republic, and Spain.